So let's add these together. So we got S plus C is going to be 200 cosine 47 plus 175 cosine 152, comma, 200 sine 47 plus 175 sine what? 152?
I need to fix the signs.
Fix the signs. No, we don't. That's why the angles are his angle. His angles do that. So then, what is our A vector going to be? The opposite of S plus C. The opposite of when you add those two vectors together. Does that make sense, everybody? First question asks, if you choose to climb in the direction of steepest ascent, what is your initial rate of ascent relative to the horizontal distance? So what vector are we searching for? If we're searching for the vector that's in the direction of the steepest rate of ascent, the what? The grad. So we want to find the grad at that point. How do we find the grad? What do we need to find? Three things. Partial x, partial y, partial z at that point 1, 3. So if we do this, zx is equal to 2x. Zy is equal to... Oh, I can almost read the entire line. You are correct. It is 5 minus 2y. And what's z? Oh, that's all we need. Do we need anything else? What is it? 3. Okay. That's nice. So what does that tell us? That tells us the direction. The direction. So the grad f at 1, 1, 3 is what? Negative 2, 3. Correct. The grad is in the direction, but also what is true? There's another thing that the grad is helpful. What do we know? Because the question is asking us, what is the initial rate of ascent relative to the horizontal distance? Yes?
Well, isn't the magnitude of the grad vector the rate of steepest,
the value of the directional derivative? Yes, it's the rate of ascent. So what is this question asking us for? It's asking us for the magnitude of that vector. So what is that? Square root of?
13.
Yes. So the gradient goes in the direction of the greatest ascent, and the magnitude of the gradient is the value of the rate of ascent. Does that make sense? Does that gradient have to be a unit vector? Is that a unit vector? No, it's not. The gradient does not have to be a unit vector, or this would really be a boring world because everything would be moving at the same speed all the time. If you're going northwest, what direction are you going in vector form? What's northwest? North, east, south, west.
Kind of like negative I and positive.
Yeah, that's great. So this would be negative 1 comma 1. So that's northwest, right? So this question is saying, if you decide to go straight northwest, will you be ascending or descending? So it's asking you to find the directional derivative and tell us whether or not the directional derivative is positive or negative. So they're asking for, z going in the northwest direction, correct? So if you want to go z in the northwest direction, I'll put a little vector hat over it. What do we need to do? How do we find a directional derivative? What's that thing we do? Dot product. Yeah, the dot product of what?
The unit vector.
And the what?
And the gradient.
Yeah, so we need the gradient at what point? 1, 1, 3 dot what? Our northwest, but unit vector, right?
Yes.
It needs to be a unit vector. Do you remember this, everybody?
Yeah.
The dot product definition of directional derivative? Okay, so we have our northwest vector, but what is it not yet? It's not a unit vector. So what is our northwest unit vector going to be? Negative 1, 1 divided by what? Root 2. Oh, do we have our gradient vector already? We do, because they made us find it in part A, or I did, by choosing this question. So z northwest is going to equal, what is it? Negative 2 comma 3 dot what? Negative 1, 1 root 2. I just keep the root 2 on the outside because I can. Are we okay so far? So let's compute this. What is it going to be? It's going to be 2 plus 3 over what? Root 2, so we have 5 over root 2. Does that make sense? So now this says, is this positive or negative? So what are we doing? Are we ascending or descending? We are ascending. Nice. Out if two vectors are perpendicular. Yeah, so here's the gradient vector, right? Let's say A, B, and the dot needs to be what? 0. So if you do the dot product here, what do you get? Negative 2A plus 3B is 0. And guess what? Maybe you'd be like, man, I only have one equation and two variables, so I can't solve this. Does it matter what the relative size of this vector? Does it matter? No, it's just asking for a direction. So it's asking for any two numbers that satisfy that equation. Can you give me a set of numbers? 3 and? 3 and 2. No, I did the same exact thing the first like 10 times I did this question. So guess what? If you go in that direction, are you going perpendicular to the gradient vector? Yes, so therefore you are at the same altitude. What are we looking for? The what? A vector, yeah. But what vector? Yes, we're finding the normal to the surface. So how do we find the normal to the surface? So we have this function, z is equal to ln x e to the y, right?
Isn't it another dot product?
No. Plane. When we're writing the equation of a plane, we need two things. What are the two things we need for the equation of a plane? We need a normal and a point, exactly. Normal and point. Well, do we have the point? 1, 2, 3. So how do you go about finding the normal? You try it first. Go ahead. See if you can find the normal vector. No, with the normal vector, it's a times
x minus x naught
plus
b y minus y naught c.
Yeah, with a lot of repetition. Z minus equals 0. And what is the normal vector right there? ABC, exactly. So we already have x naught, y naught, and z naught because we have our points. So we're searching for a, b, and c. So how do we go about doing that? Find the partial. So, okay, we need how many partials?
2.
We need 2 partials? That's my question. So what's it going to be just in terms of x, y, and z? E to the y, and then you do, and then what?
Over x. Yeah.
Over x? Like that? No, it's fine. It's all good. I needed help. I need help. Okay. What's the next one going to be? So y is changing, so what's that going to be? Isn't just ln e to the y, because what's the derivative of e to the y if y is what's changing? Oh, that's nice. And then what's the next one going to be? Negative 1. So then what do you plug into this? ER sun. So you end up with e squared over, oh, it's just e squared, huh?
Yeah.
Nice. E squared, and then you have ln of 1. What's ln of 1? 0, and then negative 1. Oh. So what do we end up with? E squared x minus 1 plus, oh, wait, that just goes away, right? So minus z minus what?
3
Equals? Voila, done. Good job. Emily, good job remembering what the key first step is, which is subtract the z. Well, there's 3 coordinate planes, right? There's the xz coordinate plane, right? There's the xy plane and the yz plane, or zy. Yeah, I do it in alphabetical, it's fine. But when you're on the xz plane, what is true? Y equals 0. When you're on the xy plane, z is equal to, and this one is x is equal to 0, right? So what do you do with each of these values? You plug them in. So if you do the first one right here, when y is 0, you end up with x minus 1 squared plus 9 plus z minus 2 squared is equal to 4. But what's the problem there? There's a problem. Do you see it? You can't have a what? Yeah, you can't have a negative radius, right? So for this first one, it doesn't. So it says, find the equations, if any, where the sphere intersects each coordinate plane. So what does this say? It means that, does this sphere touch the xz plane? Does it touch the xz plane? No. Why not? Because if this logic holds, the radius of the circle would have to be negative, and you'd have to like break time and space. Matt.
Is it because the radius is 2 and it's 3 units away from?
Well, yeah. I mean, you can logic it out. Yeah, the radius. No, because we just used logic and came up with an equation that is not solvable. It's kind of like when you do math that doesn't work, eventually you're going to get to something like 7 equals 12, and it's not true. So what does that mean? If every step along the way is fine, it means the only thing that's wrong is your original assumption. So what was our original assumption? Y could be 0. Can Y ever be 0? No. So let's do the second one here. This is a great one. But yes, going back to the original, on this one, the radius of this one is 2, and the center of the circle is
Y equals -3.
yes. Okay, so let's do the next one. Z equals 0. So what is that one going to be? X minus 1 squared plus y plus 3 squared plus 4 is equal to what? 4. What does this tell us? X minus 1 squared plus y plus 3 squared is equal to? What is it? 0. So what does that tell us? What's the only solution? What's the only solution that makes that true? -3, right. So where does this sphere touch that plane? At a point. And that's where z was equal to what? 0. So it's at the point 1, -3, 0. So this one touches at a point. So this sphere is in space, and where does it touch the xy plane? It touches the xy plane at a single point. We good with that? Okay, so the next one, yz, x is 0. So what do we have here? -1 squared plus y plus 3 squared plus z minus 2 squared is equal to 4. So that tells us that y plus 3 squared plus z minus 2 squared is equal to what? 3. So it intersects in a circle. So the sphere hits the yz plane in a circle.
Am I scrolling to the right for a second?
Yeah, sure. There you go.